Okay, we will check into the basic difference between epinephrine, norepinephrine and isoprenaline. First, epinephrine. Okay, next, norepinephrine and isoprenaline. Okay, first we have to check into the receptors it acting on. First is alpha 1. Yeah, this epinephrine acts on alpha 1 receptor, alpha 2 receptor, and beta 1 and beta 2. Next, norepinephrine doesn't act on beta 2 and it acts on only alpha 1, alpha 2, and beta 1 and beta 3. Beta 1 and 3. And the isoprenaline acts mainly on beta 1 and beta 2. No alpha action. Beta 1 and beta 2. Okay, now the properties, because as they are acting on alpha 1, 2, beta 1 and 2 is, as you all know, when alpha 1 is stimulated, it will cause vasoconstriction. So in this, diastolic BP and systolic BP both, in case of epinephrine, systolic BP increases. First, systolic BP increases and diastolic BP decreases because of beta 2 action. And overall, the mean arterial pressure will be a little above the normal. Mean arterial pressure increase. This systolic BP increase is due to alpha 1 action, and this diastolic BP decrease is due to beta 2 action. And now about norepinephrine. In case of norepinephrine, it doesn't have beta 2 action. So here systolic BP increases. Systolic BP increases and diastolic BP also increase. Diastolic BP increase, so that the mean arterial pressure so the mean will be like a little bit above the normal. Now about isoprenaline. In case of isoprenaline, it acts only on beta 1 and beta 2 receptors plus beta 3, but no alpha action. So there will fall in diastolic BP because of vasodilation due to beta 2 receptor. This fall in diastolic BP will be much more than the fall due to epinephrine. So here also systolic BP increases. Diastolic BP fall more for much less, and mean BP is also less. So now we will check into the heart rate. First about epinephrine. In case of epinephrine, heart rate will increase because diastolic BP decreases due to vasodilation. Because of this vasodilatation, there will be reflex tachycardia. So there will be tachycardia. In case of norepinephrine, there will be bradycardia. Like initially, for a small period, there will be tachycardia. Then there will be bradycardia, reflex bradycardia. Okay. In isoprenaline, there will be much more tachycardia. Much more. So now the BP. This is about heart rate. These are the main difference between these two. So their use also varies because of this difference in their receptors. First about epinephrine. Where we use epinephrine mostly? Epinephrine is the drug of choice for cardiac arrest. Cardiac arrest. because of its action on beta 1, because of the beta 1 which is present in the heart, the contractility will increase. So it is the drug of choice for cardiac arrest, and also it is the drug of choice for anaphylactic shock. Anaphylactic shock. And the reason for this is it is due to histamine release. Histamine is causing the vasoconstriction in anaphylactic shock. So here it has action on beta 2. Because of this beta 2 action, there will be bronchodilation. So it is a drug of choice for cardiac arrest, anaphylactic shock, and brittle asthma. Brittle asthma. Okay, now about norepinephrine. Norepinephrine, it doesn't have beta 2 action. So there is no vasodilatation. So it is mainly alpha 1 action which causes vasoconstriction. So it is drug of choice for vasodilatory shock. Vasodilatory shock, then and also cardiogenic shock, all conditions where we need vasoconstrictions. Cardiogenic shock. And also norepinephrine is the drug of choice for neurogenic shock, because for example, neurogenic shock in case of an accident where there is damage to thoracolumbar region and loss of ganglion. If the ganglia is lost, there will be no release of the neurotransmitter norepinephrine. So we have to give exogenously this noradrenaline, that is norepinephrine, neurogenic shock. Okay. These are the main difference between epinephrine, norepinephrine, and isoprenaline. Hope this is useful.